morning. Wanted to work with you guys today on this idea of the converse of the Pythagorean theorem, not the tennis shoes. Converse in this case means the reverse of. If a squared plus b squared equals c squared because it's a right triangle, then if a squared plus b squared equals c squared, it must be a right triangle. Okay, so it's using the rule to also prove it. Now, very bad example, but example that gets used in primary school. Well, they're a girl and they're your friend, so they must be your girlfriend. Okay, we all know that's not true, but it's that following of logic of, well, if a squared plus b squared equals c squared because it's a right triangle, then if I can prove that these two sides equal each other, then it is a right triangle. Okay, and that's what we're going to focus on today. And we're going to focus on that literally with just a couple examples. Okay, we've been working with this formula for a while. So let's take a look. What if A equals, well, I'm going to write this even differently. Okay, triangle with sides, okay, 4 inches, 5 inches, and 6 inches. Please write this down. You know that the hypotenuse of the triangle is always going to be the longest side. So C equals 6. Okay? Then A and B, the legs, it kind of doesn't matter. So I'll just do A equals 4, B equals 5. But when you are given a list of the sides of a triangle, please remember that the longest side is always the hypotenuse. And with Pythagorean theorem, that means it's going to be C. Okay? So given that information, A squared plus B squared equals C squared. Given Pythagoras' amazing formula, let's just put in the numbers. Instead of A, 4 squared. Instead of B, 5 squared. And instead of C, 6 squared. Now, order of operations. 4 times 4 is 16, plus 5 times 5 is 25, equals 6 times 6 is 36. Okay. 16 plus 25, we're going to combine like terms, is 41. 41 equals 36. No way, Jose, that's a lie. Okay, so this is not a right triangle. You just used the measurements of the triangle to prove whether or not it's a right triangle. And this one is not. Okay, now let's look at another example. Sorry. Okay. In this example, given A squared plus B squared equals C squared, and A equals the square root of 15, which we know is a little less than 4. B equals the square root of 21, which we know is getting closer to 5. And C equals 6. Now we also know both of these are like decimally crazy numbers. Watch what we can do. A squared plus B squared equals C squared. Just write down the formula every single time. Now we're going to evaluate the equation with these values. It's Instead of A, I'm going to write in the square root of 15 squared. Instead of B, I'm going to write in the square root of 21 squared. There's A's value, there's B's value, and then C is 6 squared. Remember from when we were talking about square roots that raising to the power of 2 is the inverse operation of a square root. So the square root of 15 times the square root of 15 equals 15. It undoes the square root. So now we have 15 plus 21 equals 6 times 6 is 36. Yes, it is a right triangle. And I will fix my writing right there because that is pretty awful right there. It is a right triangle. Okay? When the two sides equal each other, it is a right triangle. When the two sides do not equal, dirty rotten liar, not a right triangle. So now you're using the same formula that we've been solving for sides to prove whether or not it's a right triangle. Okay? Try a couple of these on your own, and I can't wait to see you in class.